think what I've decided to do with this assigning Lewis structure set of videos here is I'm going to split them into two. I'm going to do kind of like the more simple ones that are based on condensed structures. And then I'll have a separate video that has to do with kind of more complex Lewis structures where you have to work a little bit harder, and probably you're going to use some of the same skills that you used in your general chemistry classes. And then I am going to kind of lead into a discussion of resonance, which you probably have already seen, but in organic, resonance is going to be a much more complex, and it's going to be an argument that we apply a lot. So we're going to get a good amount of practice with that pretty early here. Okay, so the first thing we're going to do is I'm just going to write kind of a condensed structure on the board, and I'll show you how to kind of put all the pieces together. Okay, so I have a condensed structure written on the board, and it really is pretty simple to put these guys together. Obviously, we're an organic chemistry class, so it would make sense if just about all the carbons were connected. So let's do that. And we're just going to straight up connect these three carbons together. And then we're going to start to kind of see if there's any there are any functional groups in this thing that perhaps are trying to tell us something. And what I see out here is I see this very classic look of an aldehyde. Remember, anytime you see CHO or CHU or however you pronounce that, that's an aldehyde. And so it's a little helpful to kind of remember that, to know that an aldehyde is in fact this. So that's kind of one clue. And for the other groupings here, let's just put in hydrogens. And you should notice pretty quickly that there's something missing right there. This guy right here doesn't have carbons bonded 4 times. These two are only bonded 3 times. And so this is a classic kind of alkene structure here. And you would just simply put a multiple bond in there. One difference between this and what you've probably done with Lewis structures in your Chem 200 level or your Chem 220 series is that you notice that we didn't count up valence electrons. I get really uncomfortable, I'll be honest, anytime I have to take a condensed structure and turn it into some sort of expanded structure, it makes me a little nervous. So usually what I do is I go back and I do count all the valence electrons and make sure that they're all accounted for in this structure. I guess I should probably put my lone pair of electrons up there. You know, if you're nervous at any point that you screwed something up, it's always a good idea to count up all your valence electrons. And so when we get to the second video where we talk about kind of more complex Lewis structures, I'll actually talk about that explicitly if you don't remember how to do it. So there's example 1. Got a couple more examples for you, so this should be pretty quick. Here's the next example. I tried to put in a little bit more spicy meatballs in this guy. A couple of things that I noticed right away is that I noticed that I am talking about some sort of carboxylic acid. I don't think I mentioned this in the functional group video that we just had, but COOH is sometimes just abbreviated as CO2H. It's kind of 2 different ways of doing condensed structures for that carboxylic acid. So I know that that's going to be in there. So let's draw that out. So there's my carboxylic acid. And a lot of people think that, well, the carbons are all going to be connected, or I should say that oxygen is actually directly connected to that carbon. It turns out it's not. And so I'm going to kind of show you the proper way to do this particular compound. And then I'll show you kind of what you would have ended up with if you put the oxygen directly in there. Okay, so let's say, just to kind of see how you can kind of do this a little bit incorrectly, and a little bit of the struggle that would happen if you did misinterpret what this was trying to tell you. This is the correct answer, but I'm going to put down here kind of like me working through a way to kind of get the square peg to fit in the round hole here. So obviously, we still recognize that there is a carboxylic acid in here, so let's include that. And let's say that I incorrectly assign that oxygen in the middle of those two carbons, right? And then I can put in another carbon with its hydrogen and my two CH3 groups. I should also mention that I purposely didn't expand out these CH3 groups just because I'm being lazy. You could show those bonds too if you wanted to. Okay, so oops, I forgot a hydrogen. So let's put, oh no, I didn't. I got the hydrogen there. Okay, so let's say I wrote that down, and now I'm like, okay, well, I have to satisfy some octets. What could I do? Well, I guess I could, that carbon obviously isn't satisfied, so maybe I'll put a bond in there, and then I'll put another bond in here, and you say, oh, no, I can't do that. That carbon's bonded 5 times, right? So let's take that away, and I'm like really stuck for a second, and I think, okay, well, maybe that H right there, maybe it's supposed to move over. So let's move that sucker over there. Okay, well, now I guess I can put in a double bond. Oh, no, that's still got too much. So let's play some games here. Let's put in, okay, well, that is an oxygen bonded 3 times, so it must have a positive formal charge, and maybe there's a lone pair of electrons right here, which would, if I calculated it, mean that carbon had a negative charge. And so, lo and behold, I've got something that is technically correct, I guess, but the problem is that we've got a ton of formal charge where we don't need any, right? And in fact, the fact that this thing is written in this particular order means that hydrogen has to be there. So that alone is kind of a step that I did incorrectly. But if you end up with some sort of structure that has a whole bunch of formal charge, like I said, it's a bookkeeping method. And if you've done that, chances are you've done something incorrectly, especially a positive and a negative charge so close to one another like that. It's probably not going to happen. So this is, in fact, an incorrect answer. And it's a little insidious, I guess, because this, if I counted my total number of valence electrons correctly, actually matches the same amount as the correct answer. So it's, I guess, when I say that this is kind of the more simple way of doing Lewis structures, it's still, it can kind of screw you up, and you do have to kind of get used to things. I always like it if somebody is just kind, and instead of putting an oxygen just kind of hanging out alone there and risking me screwing something up here, I like it when they put a parentheses in there just so that I know automatically that that's some sort of ketone. All right, let's try one more and then we'll stop. Okay, so here's another, I guess, and slightly spicier meatball here. And you'll notice that, first of all, we've got an alcohol, and it also looks like we've got a ton of carbons without many hydrogens. Well, it turns out this is a type of functional group that we haven't really seen much before. This is called, oops, that's something that my kids have tried to destroy. This is called a phenyl group. Anytime you see that C6H5, they're always trying to tell you that that's a phenyl group, and this, of course, is an alcohol. So I just wanted to show you this just in case you happen to encounter it anywhere. And all this thing is a cyclic carbon structure that's really common that we'll have all kinds of fun talking about eventually. And then on each one of these carbons is a hydrogen, with the exception of one of them, which obviously needs some sort of CH2 with an alcohol attached to it. Okay, so we could keep going forever. If you have questions about homework, there's a bunch of these condensed structures on your homework. That would be a great thing to ask me about in office hours. This is just one of those things you just need to practice a little bit. In the next set of lectures, we're going to be talking about how to take something that's a little bit more complex. We're going to have to work a little harder on assigning the Lewis structures, and then we're going to build in to that discussion this idea of resonance.